In this video, we'll talk about finding domain and sketching compositions of functions. So I want to begin with an example, which says let f of x be equal to the square root of negative x and g of x be equal to x squared. I want to evaluate each expression and find the domain and sketch the curve. Okay, so in part A, we have f, this circle, g of x. So remember, this means a composition of functions. This means f of g of x. Okay, so if I start to plug in, this is f of, and I'm plugging in the formula for g of x, which is x squared. Okay, so whatever's in the parentheses here with my function notation, that gets plugged in to the formula for f. It gets plugged into the formula for f where the x is, where my variable is. So I will get square root of negative, and now I'm replacing this x with x squared. I get square root of negative x squared. Okay, so I have evaluated this expression. I can't simplify this more. I can't do anything with the square root and the squared because this negative is in the way. Okay, so this is my expression right here. And let's find the domain. So for this, we need to identify the restrictions. So for our domain, we need the restrictions. And I can see one restriction of this function. So if I have a square root, if I have an even root, the inside, which is negative x squared, now let me keep it in green actually, that negative x squared needs to be greater than or equal to 0. The inside of my square root has to be non-negative. Okay, and with this, I can multiply both sides by -1. And if I do that, I'll get x squared on the left. I'll get 0 on the right, because 0 times anything is 0. But if I multiply both sides by a negative, it'll flip my inequality. And I get x squared is less than or equal to 0. So at this point, I want you to do a 1-minute pause. And just in your head, see if you can think about, well, what values of x would make x squared be less than or equal to 0? This is actually something we could just work out in our heads. So pause it in 4, 3, 2, 1. Pause it for a minute and see if you can identify that. All right, let's talk about it together. So if x squared is less than or equal to 0, x can only be 0. If x was any other number, either a positive number or a negative number, when I square it, it is going to be bigger than 0. It won't be less than or equal to it. Okay, so that's interesting actually. So in terms of my restrictions, this is actually saying there's only one number in the domain. It's just 0. So our graph has just one point because there's just one value in the domain. That one point occurs when x is 0, because that's what's in the domain. And if I plug that into my formula, we get y equals the square root of, so it was square root of negative x squared. So we get negative, and I plug in 0, negative, and we get 0 squared. So this is square root of 0, which is 0. So my y value is 0. Okay, so the domain we've already identified. It's just one point. In interval notation, the way I write one point is I put curly brackets, and I write my value, and curly brackets. So for just one point. And then it said to sketch the curves. Well, so I draw some axes, and my graph is just one point. Let's sketch that point. It's at 0, 0. It's at the origin. That's my graph here. So I got the graph, and I got the domain. That's what the question wanted. All right, so let's look at B next. So in B, it wants the composition in the opposite order. So remember that f of x is, let's see, it's square root of negative x, and g of x is x squared. Okay, so this is saying, well, what is g of f of x? And f of x is square root of negative x. So whatever's in the parentheses, in this case it's the square root of negative x, that's what I got to plug in to my formula for g, for the variable x. So instead of having x squared, I'm going to have this thing that I have in my parentheses being squared. So the square root of negative x, that gets plugged in, and that is what's going to be squared. Okay, so this can be simplified. Okay, it can be simplified. Before I do, let me write down the restrictions and identify the domain. So restrictions. With this as well, I can see one restriction. The inside of the square root, the negative x, that has to be greater than or equal to 0. And just like before, I can multiply both sides of this inequality by a -1. So on the left, that'll give me x. On the right, 0 times -1, that's 0. But multiplying by the -1 flips my inequality, and I'll get a less than or equal to. Okay, so this time my domain is all values of x that are less than or equal to 0. So now if I simplify my function, when I got this root and I square it, that'll just give me -x. It'll cancel that root. But I need to make sure I write my domain restriction. So my domain is that x needs to be less than or equal to 0. Okay, so this is what my expression simplifies to. It's -x with this domain restriction. And then it said, well, whoops, then it said, let's sketch the graph. So to sketch the graph of this, let me first sketch the graph of y equals -x without the domain restriction, and then I'll put the domain restriction in. So y equals -x, well, that's a line. The y-intercept is 0, and the slope is -1. So that line looks like this. And now let's draw our function, y equals -x, with the restriction that the domain is x is less than or equal to 0. Let's draw some axes. So with this domain restriction, this is saying that x is not allowed to be a positive number. We're just going to look at the part of this graph where the x values are less than or equal to 0. And that would start here at the origin and then go onwards like this. So that is my graph. And the domain, let's put in an interval notation, is -∞ to 0 with a bracket. All right, and that is our graph. That is our domain.